Hello there, you all. Good morning. I hope you're doing alright. Hope you're doing good out there in the world. And so, in this video, we'll be discussing paracetamol, also known as acetaminophen in North America. So, for those living in that part of the universe, that part of Earth itself, it is known as acetaminophen. So, what is paracetamol? Paracetamol is an over-the-counter drug that is ubiquitous all over the world. It has analgesic and antipyretic properties. These are fancy words that mean that paracetamol will reduce the level of pain felt by the person without loss of consciousness and reduces fever, because fever happens when the temperature of the human body is drastically increased above that of 37 degrees, which is the normal body temperature. And so, yeah, what is paracetamol, chemically speaking? How does it look like? Well, imagine a benzene ring, and in the power position, you have an hydroxide on one side and an amide group on the other side, which I'll put on the screen next. The next thing to talk about this drug would be the pharmacodynamics of it. What does it do to the body? In order to understand what it does, first off, let's say what it does, which is it inhibits an enzyme called cyclooxygenase. So, in order to understand how paracetamol brings about its effect, we need to first understand how prostaglandins are synthesized in the first place. And so if you look at this setup here is just hypothetical. I'm trying to make us understand how everything here works. This is not what the enzyme looks like. This is just me trying to draw something just to make good understanding out of it. So I'm not saying this is how it looks like. I'm just using this to explain what I understand by the process. So, in order to form or make prostaglandins at local tissues in the body, a material called arachidonic acid binds to a site on the, so this is called oxygenase, right? And so cyclooxygenase enzyme has two sites. Let's call this site 1. First site 1, which is called the, so cyclooxygenase first, cyclooxygenase can be abbreviated as COX. And so calling this first site, the actual name is called cyclooxygenase site. So cyclooxygenase, this is equal to cyclooxygenase site. This is the site 1. Cyclooxygenase site. What happens here is arachidonic acid binds to the first site, and then chemically, it is converted to an unstable, so this guy comes, and then when he's leaving, he becomes an unstable intermediate called prostaglandin G subscript 2. So let's write this here. I'm going to abbreviate prostaglandin as PG. So arachidonic acid comes here, and when it leaves it becomes prostaglandin G2. So on the second site, which is called the peroxidase site, the PG2, yeah, the PG2 binds to this site, and then it becomes another intermediate called the PGH subscript 2. So PGH2, prostaglandin H2. So this PGH2 is what could be converted to, let's say, prostacyclin, could be converted to also prostaglandin E2. Now, there are two sites on the cyclooxygenase enzyme. The first site, what happens there? Arachidonic acid is converted to PGG2, which is unstable and an intermediate. PGG2 goes into the peroxidase site, and here it is converted to PGH2. Now PGH2 will be converted to other substrates by synthases which are found on the tissues in the body, on the local tissues in the body. And so this GPGE2 is what is responsible for the pain and the fever. So imagine now the site of action for paracetamol is on this second site, the peroxidase site. What paracetamol does is, in order for this site to be active, active to convert PGG2 to PGH2, it has to be in its oxidative form, like oxidative form. It is oxidized by peroxides which are around the cell, around the enzymes. So usually peroxides like hydrogen peroxide and other peroxides would be around the enzymes, which oxidizes the peroxidase site, keeps it active in order to convert PGD2 to PGH2. What paracetamol does is it acts on this peroxidase site. It acts on it as a reducing agent. So paracetamol acts on the peroxidase site, reducing the substrate, the molecules on the site, by adding electrons. So reduction could be addition of hydrogen atoms, additional electrons. Yes, those are the two definitions of reduction. You can either reduce a substrate by adding hydrogen to that substrate, or by adding electrons to that substrate, or the last one would be by removing oxygen from that substrate. So what paracetamol does is add electron to the oxygen side, keeping it inactive. So that's what it does. It keeps the peroxidase sites inactive by reduction. So what would happen when you take paracetamol, when someone takes paracetamol, is as the arachidonic acid is being converted to PGG2. PGG2 comes here, and then the peroxidase site is inactive. It is not able to convert the PGG2 to PGH2. If there is no PGH2, then there will be no PGE2, there will be no pain, there will be no fever. Or even if there is pain, there will be no amplification of the pain by sensitizing the receptors around the tissue. So with that, I hope you now understand, I hope I've been able to pass the information, well, you've been able to learn one or two about paracetamol. And yeah, so let's move on to the pharmacodynamic and pharmacokinetics of this drug. So it is available in the form of tablets, in the form of syrups, elixirs, even injections. So let's behave like we are the drug, because let's say orally you take a tablet of paracetamol, it goes to the mouth, through the mouth, serves the gut, stomach, and the small intestine is where it is most absorbed. And so on absorption, where does it go? It goes to the liver first, where first pass mechanism happens. The first pass mechanism is a process which reduces the bioavailability of the drug in the systemic circulation, because for drugs taken orally through the gut, basically they do not have a high bioavailability. Now I'm going too far. I have to explain what bioavailability is and blah blah blah. Just bioavailability is the bioavailability is the fraction of the drug that is available or present in the blood plasma. The fraction of the drug which actually gets used in treating the disease, that's bioavailability. And for routes like intravenous routes of drug administration, the bioavailability is nearly 100%, because there is no first pass mechanism, there is no metabolism of the drug before going into systems. It's already going directly into the system. Your veins is already in systemic circulation. So, where was I? The drug gets absorbed. Not everything is absorbed because it is not intravenous. It goes to the liver where it is metabolized. Let's talk about metabolism of paracetamol. Imagine you've taken the drug, the bioavailability of the drug, the fraction of the drug that gets to systemic circulation has gotten there. It has gone to the site of action, the peroxidase site. It has done what you want it to do, which is reduce the production of prostaglandin E2. And now it's time for the drug to leave the body. It's time for the drug to get out you've treated what you wanted. You've reduced the fever and you've reduced the pain. So it's time for the drug to go. How does the drug leave? Well, in the liver, where it is mostly metabolized, metabolism is done to the drug in order for it to become soluble and easily excreted from the body. You see, most of the drugs we take in are hardly soluble in water in aqueous solution, and so the body has to metabolize these drugs in order to make them more soluble in aqueous solution. The significance of metabolism of drugs is so that the drug becomes soluble in aqueous solution, so it is easier, better to get the drug out of the body, because if the drug stays in the body, accumulation of the drug will cause toxicity and cell death and can get worse for the person. In metabolism, there are two stages to that. There is phase 1 metabolism and phase 2 metabolism. But recently, there is phase 3, but I don't really know much about that. So what I know about is there is phase 1, there is phase 2. In phase 1, there is one metabolite I want to talk about, which is what I call NAPIQ, NAPQI. So in phase 1 of paracetamol metabolism, one of the metabolites paracetamol is converted to is N-acetyl paraquinone. Because I call it NAPQI. This specific metabolite is then conjugated with a substrate called glutathione. Glutathione, on adding to NAPQI, makes it soluble and excretable. So in the case of overdosing, the concentration of NAPQI is so high that the rate of production of glutathione is relatively low to the rate of consumption of the glutathione by the NAPQI. So when this happens, it gets to a point where there is no more, or there is little or no more molecules of glutathione left in order to convert NAPQI to a excretable substance. And so the concentration of NAPQI is increased. So what happens is it accumulates on the cells of the liver, and it does something really bad, which is it binds to the mitochondrial proteins of liver cells, causing oxidative stress to be increased and therefore toxicity. Mitochondria is the powerhouse of the cell, and if you damage its protein, you're not getting good use of oxygen. There is no metabolism in the cell, and so it leads to cell death. Cell death of liver would cause actual death of the liver, and the liver is a vital organ in the body. If the liver is damaged, death could happen, and so that's what happens in the cases of overdosing. Also, in the case of chronic use, it could reduce the level of hemoglobin in the body. Hemoglobin is the complex, the structure that carries oxygen from the lungs, in red blood cells, and everywhere else in the body. So imagine that is reduced, hence there'll be reduction in the supply of oxygen to the body. Chronic means using something for an extended period of time. So imagine someone takes paracetamol every single day for a year. Oof. So what else do I want to talk about in paracetamol? I think that's all for now. Yes, yes, that's it. Alright, if the video was helpful and you learned one or two from it, then I would love it if you do not forget to subscribe, like and subscribe, because yeah, that would show support towards my channel, towards me, because this is not easy. Though I love it, it is not easy making videos. And so yeah, thank you very much for watching. Guess I'll catch you later. Bye.